All right, so in this video, we are going to be discussing 2.6, topic number 1, solving equations with rational exponents. So let's take a look at what this means. So if you remember that when you have a base of some number, so let's just say b, it is power over root. So maybe that's how you can remember it. It's power over root, which simply just means that this is the cubed root of 8, and then we want to square it. Now, you could square the 8 first and then take the cubed root of that. There's lots of ways to do this, but personally, I think it's better to work with smaller numbers. So if I were to cube the cube root of 8, that is going to give me 2, and then I get 2 squared, and that's going to give me 4. So this answer is 4. So now I would like you to do the you try, and then I'll come and have you check your work. So on this one, we've got this negative exponent, which means that you have a fraction. So we're going to go 1 over 64 to the 1/3, which is the same thing as 1 over the cubed root of 64. And so if you were to cake it whichever direction you want, if we were to go and just figure out how many what the cubed root of 64 is, we would just keep dividing by the lowest prime. And, oops, it's going to be 4. And then you stop when you get a 1. And then now we are circling groups of 3 because it is the cubed root. So I have one set of 2's, and then I have another set of 2's. So that's going to end up giving me 1 over 4. Now, let's go into solving equations involving these. So the idea or the takeaway, and I would love for you to be able to add to your toolbox section right here, would be to raise to the reciprocal power, because when you have a power to a power, you multiply, and then whatever you do to one side, you do to the other side. So when we simplify this, we're just going to be left with x is equal to the 5th root of 32 to the 4th power. So if I were to think about the 5th root of 32, the 5th root of 32 is 2, and then 2 to the 4th is 16. All right, so now let's take a look. We have variables on both sides. So what we're going to do is rewrite this so that it is set equal to 0. We want to get our variables on one side. And so if you remember, we did some factoring of this back in section 1.5. I think it was called factoring complex expressions, and that was Roman numeral 5 on your notes. So refer back to this to help recall the process for that. So the idea when you have exponents with powers, you want to be able to take out the smallest power. So in this case, it is 1/2. So I have x to the 1/2, and then I'm going to basically divide x to the 1/2 to every term. All right, so now I have a situation where I have 3, but I need to simplify this portion right here. So if I were to go and do my work right here, it's the same thing as x to the 3/4 divided by x to the 1/2, which according to those properties, it is the top minus the bottom. Now, if you were to think about that, 1/2 can be rewritten as 2/4, and so what I get is x to the 1/4. So when I simplify that, I'm going to get x to the 1/4. So I got 3x to the 1/4. Believe this was a minus sign, and then x to the 1/2 divided by x to the 1/2 is just 1. And so now we can set each factor equal to 0 and solve. And so again, you're utilizing the technique of the reciprocal power. So x is equal to 0 squared. So in that case, it's kind of obvious that x is 0. But in this case, let's go ahead and solve for x. Let's add 1 to the other side. Now let's divide by 3. So I get x to the 1/4 is equal to 1/3. And then I'm going to raise it to the reciprocal power, which is just 4. So I get x is equal to 1/81. So I have two answers for this particular problem.